I bet you didn't know the true power of data. Once upon a time in the world of machine learning, data was the king. It was the foundation upon which all models were built, the raw material that fueled the algorithms, and the key to unlocking insights and making informed decisions. But there was a secret sauce that made this kingdom thrive: feature engineering. In its natural form, raw data was often messy, unstructured, and difficult for algorithms to understand. It came from various sources in different formats and with numerous inconsistencies. This chaotic nature of raw data made it challenging to extract meaningful information directly. Enter feature engineering, the art and science of transforming raw data into meaningful features that machine learning models could use to make accurate predictions. It involved selecting the right variables, creating new ones, and transforming existing ones to better represent the underlying patterns in the data. Imagine trying to bake a cake with just flour, sugar, and eggs. You need to carefully measure, mix, and bake these ingredients to create a delicious treat. Similarly, in feature engineering, we needed to carefully process and transform our data to create features that would be useful for our models. Just like baking, feature engineering prepared data for the machine learning process, ensuring that models had the right ingredients for success. This involved cleaning the data, handling missing values, encoding categorical variables, and scaling numerical features. Feature engineering was a critical step in the machine learning pipeline, bridging the gap between raw data and effective models. It transformed raw data into a format suitable for machine learning algorithms, making it possible to build models that could learn from the data and make accurate predictions. By carefully selecting, transforming, and creating features, data scientists empowered their algorithms to uncover hidden patterns, make sense of complex relationships, and ultimately, make better predictions. This process required a deep understanding of the data, the domain, and the machine learning algorithms being used. Just as a skilled chef could transform simple ingredients into a culinary masterpiece, a proficient data scientist could leverage feature engineering to unlock the full potential of their data. With the right features, machine learning models achieved higher accuracy, better generalization, and more reliable predictions, ultimately leading to more impactful insights and decisions. And so, the kingdom of data thrived thanks to the magic of feature engineering. You need to hear this if you're a data scientist. Imagine you're a detective piecing together clues to solve a mystery. In the world of data science, this detective work is known as feature engineering. It's the art of transforming raw data into a format that machine learning algorithms can understand and use effectively. Think of it as turning scattered clues into a coherent story that leads to the truth. Our detective work involves selecting, manipulating, and creating features that best represent the hidden patterns and relationships within the data. This can include techniques like normalization, encoding categorical variables, and creating interaction terms. Each step requires a deep understanding of both the data and the problem at hand. Essentially, we're engineering the clues that will help our models solve the mystery. These features are the inputs that the machine learning algorithms will use to learn and make predictions. The better the clues, the better the model's performance. Let's dive into a real-world example: predicting house prices. Imagine you have raw data with features like square footage, number of bedrooms, and location. These are basic clues that provide some information about the property. However, these raw clues alone might not capture all the nuances that influence house prices. Simply feeding these raw features into a model might not be enough. The model might miss out on important contextual information that could improve its predictions. This is where our detective skills come into play. Feature engineering could involve creating new features like distance to the nearest school, average income in the neighborhood, or even the age of the house. These engineered features can provide more context and help the model make more accurate predictions. By transforming and enriching the original features, we provide the model with a more comprehensive and insightful view of the data. This enriched data set allows the model to understand the data better and make more informed predictions, ultimately leading to more accurate and reliable results. So the next time you think about feature engineering, remember, it's all about being a detective, turning raw clues into a compelling story that leads to the truth. And in the world of data science, that truth is accurate, reliable predictions. This is why you need feature engineering. Imagine you're a detective, sifting through mountains of clues to solve a mystery. In the world of data science, This is what feature engineering feels like. It's a crucial step in our journey, where we transform raw data into meaningful insights, unlocking the predictive power hidden within. Let's dive into some essential techniques that data scientists use to enhance their datasets and improve model performance. First up, categorical encoding. Picture a dataset filled with colorful categories like cities, colors, or even types of cuisine. Machine learning models prefer numbers, so we need to convert these categories into numerical values. Techniques like one-hot encoding, label encoding, and ordinal encoding come to the rescue. One-hot encoding creates binary columns for each category, while label encoding assigns a unique number to each category. Ordinal encoding is used when the categories have a meaningful order. Next, we have feature scaling. Imagine trying to compare the heights of mountains and molehills on the same scale. Features in a dataset often have different ranges, like age and income. Feature scaling techniques such as standardization and normalization bring all features to a similar scale. Standardization transforms features to have a mean of 0 and a standard deviation of 1, while normalization scales features to a range between 0 and 1. This ensures that each feature contributes equally to the model's learning process. Finally, let's talk about feature creation. This is where creativity meets data science. By combining existing features or extracting new ones, we can uncover hidden patterns. For instance, combining height and weight to create a body mass index feature, or extracting the day of the week from a date feature, can provide valuable insights. This process often requires a deep understanding of the data and the problem at hand, but the rewards are worth it. By generating new features, we can capture additional patterns and relationships within the data, leading to more accurate and robust models. You need to hear this if you're a data scientist. Imagine you're a chef, standing in front of a pantry filled with countless ingredients. Just like a chef, a data scientist must carefully choose the right ingredients for their model. Not all ingredients are created equal. Some spices might be essential, while others could be completely unnecessary. Similarly, some features in your dataset might be irrelevant to your prediction task. Others might be redundant or highly correlated with other features, adding no real value. Including too many irrelevant or redundant features can clutter your model, leading to overfitting. Overfitting is like a chef adding too many spices, where the dish loses its essence and becomes a mess. Feature selection techniques help identify the most relevant and informative features for your model, improving accuracy, reducing complexity, and enhancing interpretability. Some popular techniques include recursive feature elimination, or RFE. This iterative method starts with all features and recursively removes the least important ones until the desired number of features is reached. Lasso regression. This regression technique incorporates a penalty term that shrinks the coefficients of less important features to 0, effectively performing feature selection. You need to hear this if you're a data scientist diving deep into the world of machine learning. You encounter 3 formidable foes: overfitting, underfitting, and missing values. Each of these challenges can make or break your model's performance. Let's explore these common pitfalls and how to conquer them. First up, overfitting. This happens when your model becomes a perfectionist, memorizing the training data, including all its noise and outliers. The result? It struggles to generalize to new unseen data. To combat overfitting, you can use regularization techniques, carefully select features, or simply gather more data. Next, we have underfitting. This occurs when your model is too simplistic, failing to capture the underlying patterns in the data. It performs poorly on both training and testing data. To tackle underfitting, consider using more complex models, adding more features, or reducing regularization. Finally, let's talk about missing values. Real-world datasets are often incomplete, with missing values scattered throughout. You can handle missing values through imputation, which involves replacing them with estimated values. Alternatively, you can use algorithms designed to handle missing data, or you might choose to remove rows or columns with missing values altogether. By mastering these techniques, you'll be well equipped to navigate the challenges of feature engineering. Why are there not more people talking about the power of Pandas and Scikit-learn for feature engineering? Imagine you're a data scientist, diving into the world of feature engineering. Your trusty companions, Pandas and Scikit-learn. With Python, you have powerful allies. First up, Pandas. Picture this: a library that offers data structures like data frames, perfect for data manipulation, cleaning, and transformation. Its intuitive syntax and rich functionality make it an indispensable tool in your feature engineering toolkit. Now meet Scikit-learn. This machine learning library is like a Swiss Army knife, offering a wide range of algorithms for classification, regression, clustering, and more. Plus, it includes essential tools for pre-processing data from feature scaling and encoding to feature selection. Together, Pandas and Scikit-learn are your ultimate feature engineering duo. If you found this guide helpful, don't forget to subscribe, like, comment, and share. Your support helps us create more valuable content for you.